let's really get into diagrams. These are excellent ways of finding the image distance of our problems. So, we use radius diagrams to locate the image formed by a mirror. These are always drawn to scale, so make sure you're very careful that you're always drawing them to scale, and use a ruler. We're going to draw 3 reference rays. Now, you only need 2 to see where it's formed. Okay, basically the image is wherever your 2 reference rays intersect. Let's do a couple. Here are the 3 rays you need to know. From the object to the mirror, and then from the mirror after reflection. All right, the first one is in parallel, and it's always parallel to the principal axis here. All right, so this is called the P wave. In parallel and out through the focus. So it's going to bounce off through the focus. Use a ruler. The second wave ray is called the F wave, and that's called in through the focus. So start at the top of your object and go through the focus, and it's going to bounce off parallel to the principal axis. So that's going to be parallel. And the third one is straight through the center of curvature and back on itself. Now, these aren't so easy to see, so let's do some with rays. All right, in parallel, it hits the back of the mirror, always draw on the back of your mirror, and it's going to bounce off through the focus. So you can all do that. In parallel, out through the focus. The second one, you start at the top of the object and you go through the focus until you hit the back of the mirror, and then you're going to bounce off parallel. So this one's in through the focus, out parallel. Now the third one is straight through the center of curvature. Now this one doesn't have to hit the mirror because a lot of times this will be on your neighbor's paper. So you start at the center of curvature, hit the top of the object, and dot back until you hit where they all intersect. Your image is always going to start on the principal axis and then go down to where these 3 rays intersect. Now, clearly, this image is inverted because it's upside down. The object is pointing up, the image is pointing down. It's enlarged because it's bigger than the object, or we might say m is greater than 1, absolute value of m. And it's real because the rays really did cross there. We didn't have to do anything funky to get them. Now, as you move the object, you're going to see a number of things. If the object's further from the mirror than the focus, then the image is real and inverted. So whenever SO is greater than the focus, you get real and inverted images. If it's at the focal point, so the object is sitting at the focus, we're not going to get an image at all. And if the object is between the focus and the mirror, so SO is less than the focus, we're going to get a virtual and upright image. Let's do those. All right, we're going to look at 2 cases of what happens when the rays do not actually intersect. This is always going to happen when you're on the focus. You see the object, my arrow here is sitting on the focus, or whenever you're inside the focus. Let's do these one at a time. What happens when you're sitting on the focus? Well, first, draw the back of your mirror. That's very important. Remember the first ray? In parallel, out through the focus. You do the same thing you've always done. In parallel, out through the focus. What's the next ray? In through the focus, out parallel. Now, we have a problem here because to go from the top of the object through the focus, we get this vertical line. Can't really do it. You don't have to draw it for me. That's okay. And then, of course, the third ray is through the center of curvature to the top of the object and back. Now, you see, these 2 rays are parallel. You don't get an image. There is no image formed when you're on the focus. F, it's not what you want. There is no image when you're sitting on the focus. If you're not focused in class, you're going to wind up with an F. Think about that. Okay, that wasn't very funny. Now, what if you're inside the focus? Let's do these ray diagrams. First, draw on the back of your mirror. That's very important. Now, you're going to go in parallel and bounce off through the focus. That's fine. You don't do anything different just yet. Then you're going to go in through the focus and bounce off parallel. Now, you're starting to see there's a problem because you're always looking for the intersection of the reflected rays. Now, here's the trick. Here's a reflected ray and here's a reflected ray. They're not intersecting. Now, draw in through the center of curvature and back, and you'll see these three rays do not intersect. Okay, you're always looking again for the reflected rays. So what do? Well, you have a virtual image. You need to dot your reflected rays back. So this one was reflected, so you dot this one back. Don't dot this one back because that's an incident ray. The one through the center of curvature always goes straight. You can just carry that one through. And then in parallel out through the focus, this is the ray you dot back. And of course, where the three rays intersect, that's your image. So you have a virtual, upright, magnified image here.